Hi, everyone. Thank you so much for joining us today. My name is Tara O'Hare, and I'm from EPA's WaterSense program, and I'm very pleased to be here today with Anneke Chamberlain and Frank Burns of Meemere Water. Anneke is the founding director of Meemere Water. She has deep expertise in implementing water efficiency programs for municipal water providers, industrial manufacturing facilities, and commercial property operations. And also today, returning as the speaker for Water Wednesday is Frank Burns. Frank is the original founder of Apana Incorporated and is now the technical director for Meemere Water. Frank has deep expertise in optimizing water use inside of buildings, irrigation systems, cooling towers, and processes common to commercial, industrial, and institutional properties. He has 6 patents and 29 years of project appointments with the most noteworthy Fortune 500 companies. Thanks so much. So Frank, if you could go forward 2 slides. Today is just one of the first Water Wednesday webinars that we are doing, and we have a whole series of them in the next few months. And I encourage you to join us and find out more. So thank you so much for joining us. Frank, I'm going to pass things over to you.
Fantastic. Thanks, Tara, and welcome everybody. Looks like we have a big group of people from, well, literally across the country and a number of different perspectives on this subject matter, and we're excited to be presenting a construct that we've been developing, or we believe is something that will help us as a group, as a profession, gain a lot more speed with integration of water efficiency across commercial, industrial, and institutional sector properties. We're going to move quickly, and again, this is recorded. You'll get the resource for future reference. I'm just going to dive in. In a lot of places, we have a lot more demand for water than we have supply. Gotten kind of obvious lately. And so the real simple, deceivingly simple idea is, why don't we just eliminate the part of our current water use that's not necessary? We'll eliminate the waste. And that's a fantastic idea, but there are some connection points that we absolutely have to make in order for that to become possible. And that's what we're going to talk about today. And we're going to talk about how to engage commercial properties, large organizations that have a fleet of commercial properties, and cities, so that they can gain water efficiency across their commercial, industrial, and institutional sector properties. And it will have some of the concept ideas, and it will deliver takeaways that you can use right away. From adult learning, advancements in adult learning, what they're saying is that in order to create learning, you have to start with a common referenceable point, and then you add the new information from that common point and build out so that understanding takes place. When we think of operationalizing water efficiency so that it is a habit, that it is a routine, that it's a reflex, the best referenceable analogy that we've been able to come up with is recycling. For most of us, recycling is something that we don't think a lot about. We just do it. We've operationalized it to the point it's a reflex. It wasn't always that way. Originally, the idea was met with quite a bit of skepticism, and it wasn't until the avoided cost model became so obvious that they began to figure out ways to make it really simple for people to be successful with recycling. And people, for example, people were already taking their garbage to the curb. They just needed a separate set of bins to put the recyclables in, and then they would take those to the curb along with their trash. And that is what Tara refers to as habit stacking. There was this existing habit, they put a new habit on it, and it became easy enough, refined enough, that it became successful, quite successful. And now we actually even have the blue bin. So recycling's a reflex now, but it started as an idea to avoid costs, and we think that this common reference point could help all of us nudge water efficiency to that sort of level. And that's important because when the first person stood on the moon, when I was, less than a year old, they looked back and saw 3.3 billion of us. Now there's 7.7 billion people. And when you start considering that water is the #1 consumer of electricity in most cities in North America, and that we're having scarcity issues, this is worth dealing with effectively. And so we're looking forward and we're seeing these costs, these problems, and environmental impacts, and how do we get in front of them without, hyperventilating. So we're going to dive in and cover a lot of the details of that. But before we can run forward with things that we can take and implement, we need to have a common understanding of some of the realities that we confront, and that the formula that we're suggesting could help all of us, how it applies so that the tricks of the trade can be integrated quickly across properties, hopefully everywhere. So what we've learned from 30 years of working with Fortune 500 companies, very successful operations, is that when they have a new idea that they're integrating, there's a construct that they use to shape the idea, test it, evaluate it, and operationalize it. And water efficiency can use this same approach to integrate better with operations, with or organizations, but we have to change, we have to evolve our approach so that our recommendations are very refined and honed so that they're easy enough to connect so that they can become habits and they can become routine, just like recycling did. And so to get there, to get to that point, there are two big realities that we feel opened our eyes to a lot of things that became obvious after we embraced these two basic ideas. The first idea is that that in order to operationalize water efficiency, everything has to be honed for success at the property level, because that is where the problems are. All of the problems are inside of a property. You take the property line and you break it in. We break it into 3 common referenceable parts: outside, inside, and cooling. But that's where the problems are. They're at those endpoints there. So this is an important thing to remember, because if we don't design everything for success at this level, we have a disconnect, and that's when things fail. The second reality is that every one of these properties typically has somebody in charge of it. We call them the property operator. They start their day running. It gets chaotic from there. Operators get things done. They want very actionable, implementable things to do. They don't want an ambiguous idea. If we're going to make water efficiency a habit, a routine, much like society was capable of making recycling that way, we have to connect with these property operators. We have to have them engage in our plan and say, yeah, that's what we're going to do. Otherwise, there's a disconnect and things go sideways. So once we fully embrace this idea of, okay, it's at the property, we have to be successful there, the property operator is our bottleneck, we began to rethink a lot of the things that we had done historically, and we realized that, wow, these people have a relatively standard thought process and way of evaluating new ideas and integrating them. If we could just take that idea development process that these successful companies are already using and connect with that, and that would speed the adoption and would make us much more engaging, speed the engagement, which puts us on the path. So here is a example of that thought process. that successful organizations use. When they have a brand new idea, it's in the ad hoc, just wing it phase. They're kicking the idea around, forming it so that they can test it for repeatability. Once they have an idea like, oh, okay, this is a well enough formed idea, they test, repeat, with the intention of figuring out how they're going to create a plan with routines to operationalize it. It is that level 3 that has to be achieved before an idea can actually be integrated into a successful organization. Once that level 3, a plan with a routine to implement efficiently and effectively, is established, successful organizations are absolutely brilliant at measurement, management, and driving optimization. Those things don't connect unless level 3 is achieved. We have a lot of examples for that. But one of the our questions, well, an example of this construct, this mindset is, think of when you go to a grocery store, there's a lot of stuff there for us. Grocery, inventory control inside of grocery operations is absolutely fundamental to their success. They're so good at it, we don't even know it's happening. But we walk into a grocery store and we can buy fresh produce, we can buy things that are frozen, things that are refrigerated, and we take them and we have somebody who's really nice to us who checks us out and we pay them and we leave. That entire chain of things was inventory control. And grocery as an industry is so brilliant with this, it's a reflex for them. When they have a new product come in, it's at the idea stage. They figure out, okay, how is it going to arrive? Where are we going to put it? Test it. Then they make the plan, and then it's operationalized. They measure, manage, and then optimize that inventory concept inside of grocery, and all of us don't even realize it's happening. But if we, as an industry as a profession with water management, if we could just connect to that sort of brilliance, holy cow, we'll run a lot faster. So the question is how do we take the fleet of commercial properties with all of the things that are going on and move them from this idea of, oh, I have a water goal, or I know we should be avoiding wasteful water use. How do we get them from that to the point that they're successful with it and on a path? We give them a plan. And we think that if we approach consistently everybody with this idea of we're going to make this efficiency as routine as you have for your operations of recycling, and we give them a plan to achieve that, we're going to have a lot more success. Aniki has a great example about the disconnect that happens if we don't have the people who are operating our property connect to the idea.
Yeah, when I worked at cities, oftentimes if a commercial facility had high water use or something, we would send them a high water use alert or a leak alert. But we'd see month after month, we'd send them the alert, the water obviously had a leak. So we'd think, oh my gosh, these commercial properties just don't care about water. But then we get to the property and we help them and we realize they do care. They just didn't know what to do with the information, right? They get the leak alert, but they don't know where the end uses are on their property, how they're supposed to operate. So it's information that's not actionable. So if we can take our focus on helping the commercial properties understand where their end uses are, how they're supposed to operate, and build on that with this plan with routine, they can be ahead of those or in control of those water uses every day. Then as AMI and all this advanced measurement comes online, when they get that leak alert, they know that's completely actionable information. They know where the points they need to go to look at it and what to identify.
So at a property level, and again, that is where everything has to be designed to create that success. Otherwise, it won't scale across a fleet of properties and cities. This is what it looks like. We take that busy property operator and we give them a repeatable plan and it can be very simple. but we give them routines that they can delegate to people who are already inside of the property doing things. Property operators have staff. They have service providers. They might have districts and regions and divisions. We give them routines that they can delegate to people already there. Upon that, take whatever they have for measurement and connect it so that it drives optimization. And as Aniki suggested, measurement is going to improve significantly, and there's a lot of good things coming there. One of the big things that we want to communicate here is we're not training property operators to be experts at the technical aspects of all of their equipment. We're going to show you how we just connect a couple of insights to let them to be a toggle switch on, is it operating right or is it clearly failing? That is what is going to drive, that's what drives success. And at a city and large organization with a fleet of property level, it's that property level success that then goes across the organization and fleet that then helps all of us as a society establish sustainable success across cities where it makes sense to do that. And we think that this is pretty relevant because our gut is telling us that people are looking toward big organizations in cities for leadership on how to address all of the things they're hearing about water and energy impact. And we see that both large organizations and cities are very well prepared to deliver on this, much like they delivered on recycling. And the nice thing is, or we think a good thing is that the avoided cost model associated with water efficiency is far more compelling than what recycling was. There's a lot of expense and complication that we can avoid if we do this right. But to avoid that, we have to have a formula that's replicable, that we can to operationalize the efficiency so that it becomes a habit. Again, with adult education, you start from a common reference point and build out the understanding. A trick that we use is the toilet, because pretty much everybody knows what it is. And if this toilet has a relatively small leak, it is a 1 gallon a minute leak. It can be 1,440 gallons in a day, and that's enough for 4 homes. So we take that idea of a toilet, small leak, enough for 4 homes in a day, oh my goodness, and expand it. The toilets are a relatively minor offender when you consider the hundreds of other failure points outside, inside, and in cooling across commercial properties. That's when we use that to expand it, to expand the knowledge base up. And then the Environmental Protection Agency's estimates are that about 50% of the outside water use is avoidable. Our data suggests it's higher. EPA is too nice. Inside of the buildings, the data suggests about a little over 20% that could be avoided. And then in cooling applications, properties that have cooling applications, the avoidable water use is far closer to the outside area. So what we're going to do now is we're going to take that formula, that construct that we were talking about, we're going to apply it to outside, and then to inside, and then to cooling, show you how that goes. And Aniki's going to walk us through outside.
Thanks. So we're applying this concept in City of Spokane. So I'm going to kind of walk you through the formula for how we approach outside, the outside aspect. I'm going to walk you through using an example from a fire station. So if you go to the next slide. So first thing we're doing kind of our 3 steps to optimal efficiency. First thing we're doing is fixing problems, right? So at the fire station, we found leaks, we found crazy stuff. Rodents had chewed elbows underground, and there was huge caverns and stuff that were just very difficult to see. So we went and fixed all the broken parts. Next, we basically found what the optimal water use was for the fire station. Now, fire stations have they want to look good. That's their in the community. So we're not looking to restrict use. We want them to look good with the optimal water use. So we basically create the budget, right, using landscape area, vegetation type, weather. So we know what their optimal water use is. Next, we go into control. So there's options with irrigation controllers or watering schedules. At this facility, we put in a weather-based irrigation controller, did a little training, have some measurement options, monthly measurement. But really what it comes down to is that defining that standard operating procedure that's going to keep all of this efficient over time. So for this facility, there were 7 zones. So we worked them, oh, well, what's your normal routine? They said we mow once a week. In fact, I just mowed this morning. I was like, oh, well, we can just go out and turn on each zone 2 minutes, take a quick eyeball check, and see if we have any breaks or leaks. I can do that. So I'm like, let's do it. We went out, turned on the zone. That morning, the mower had busted off a sprinkler head. There was a geyser there, and the guy was like, oh, my gosh, that would have gone at least a month. I'm like, I know. So every now and then, he'll send us emails saying, oh, I found a new leak today. So a good example of engaging that staff, getting that operating procedure to maintain, because there's always going to be breaks in irrigation. So that's a good example for irrigation. There's another project that we did in Spokane, and this just so clearly shows the improvements that can be made. A facility that was using about 60,000 gallons of water a day needed about 10. So it went in, as you can see, there are about 58,000 gallons. First step, fix the problems, immediate drop to about 37,000 gallons. Then next we went in on the operational, the controls, adjusted the irrigation schedule, put in some operating procedures, and very quickly we're down to 60% reduction. They still had another half to go, but this is a very good example of how systematic that works.
So that's outside, and what you're going to see is that formula that Aniki presented of find and fix the problems, identify what actual optimal use is, and then control the water as close to optimal as possible. It works inside as well, but inside has a different component. And when we go inside of commercial properties, the one thing we're really front of mind as we enter is to eliminate the defensiveness around, oh my gosh, what are you guys up to and going to do? So we begin with asking them, are you using enough water? And we explain that in their food processing cleanup, they have to have enough water for sanitation, otherwise they're going to have food safety issues. And toilets must be clean and flush. So our goal is to reduce waste. It's not to restrict water use. That combination there helps us get in front of a lot of craziness that we just don't have time to deal with, to be honest with you. We then land the idea that we're going to give them easy to delegate steps that are going to help them gain control across their property, the things that their vulnerabilities. And again, we start with the toilet, and we show them that we use this to help them realize that they have internal experts on staff doing things, and we just need to do that last millimeter connection to gain control of this. Commercial properties have people who clean the toilets 2, 3, 4 times a day. If we can train those people to look for a ripple of water of where the porcelain meets the water, on the edge of the water, that identifies a leak, and then we ask them to report it. When they're done cleaning, if they flush the toilet and that valve, and it sticks and runs for a lot longer than the other toilets, they just identified a stuck valve, report that, and that can be fixed. We take that idea, apply it to urinals, faucets, and fixtures. Now this commercial property has identification of problems and control across their bathrooms. This construct then bumps up one more level to let's train staff to actually be able to identify waste, see it as they walk and work. And we had a grocery client that we asked the manager, do you walk around your building 2 to 3 times in a day? And they're like, no. It's 12 to 20 times in a day. And we're like, good. Because anytime you have a failure, you're walking past it. And what we want to do is we want to just connect to that routine that you have and have you be able to see the failures that very frequently go unnoticed. not necessarily be an expert, but have enough information to be able to see stuff. And so we call it the train for the drain trick, because most complex equipment, hot water heaters, water softeners, filter systems, reverse osmosis systems, bakery ovens, all of these things that are connected to water likely fail into a drain. For example, if you have a gallon of water on the floor, you know it's a failure. You know that's a problem. But if you have a piece of equipment draining a gallon of water into a drain, water's supposed to flow into the drain. Is that a problem? So we train them that these things all may discharge intermittently, a little bit. They shouldn't run continuously into the drain. So as you walk through, if it's always running, likely there's a problem. That's the difference. And it's a pretty simple thing. Now they'll be able to see the waste and stop it. So, from a management perspective, it's this idea of a standard operating procedure. Call it a habit stack, call it a trick of the trade, whatever. We're taking and just showing the staff what to look for in a way that's really refined, simple, clean, implementable, and then included into their existing checklist. And for gosh sakes, leverage the superpower of management. When somebody brings up one of these things, recognize the success, say, oh my gosh, you've probably just saved enough to feed homes, and hopefully reinforce that. And then we're off from a routine to hopefully a culture. Now, Aniki, this idea of train the brain to see the drain thing, no presentation would be complete without the super ironic story, and water efficiency has lots of these, and Niki's got a great story for us. Actually, I'm just going to go back to that slide because it's so, okay.
So yeah, I went to a facility that had a massive, usually just used a couple thousand gallons a month, got a monthly water bill that was like 2.5 million gallons. So go to the facility, check it out, see what we can do to help. It's a facility that actually makes cooling towers. They manufacture them there. So we're on the production floor. And long story short, basically their main cooling tower had kind of a collection system, but the main cooling tower was inside on the shop floor. So the water supply, the drain, the blowdown, or the overflow all had a drain right there. So what had happened was the supply got stuck on, the machine was overflowing through the overflow pipe and going into the drain at an incredibly high rate. And everybody was walking by it every day, running constantly, and nobody realized that the machine had failed because the water was going into a drain. And the irony is that making cooling towers still didn't really understand that constant flow was a problem. So pretty funny, but that's an excellent example of where just that basic, train for the drain. If you look there, it's constantly flowing. Bam, you got a problem.
And it reinforces this idea that we need to get the discipline of water efficiency to the point that we have a plan with a routine that operational staff or organizations say, yeah, we support that. Then it connects, because there was a disconnect. And these are people that absolutely know how these things work, but they didn't connect to that last. That was like maybe 1/4 of a millimeter disconnect, but a clear example. So moving from the outside inside into cooling, it's the same thing. Find and fix the problems, figure out what optimal water use is, and then control that. And I was lead author on a big study about cooling towers, and we ended up realizing that cooling, when it is part of a property, is a significant part of the total water use. And some of the findings, one of the high findings from the study, this was a 3-year study using minute resolution, real-time reporting, and it was eventually 100 different units across the country. But the big finding was that most of the units were operated in a wasteful to very wasteful range. And by that I mean that they didn't use the water as many times as they could. So when you have optimal, it's like the maximum number of times you can actually cycle the water. And on this graph over here to the right, you'll see on the bottom, it's COC, which is cycles of concentration, the number of times you use it. And then on the y-axis, each time it shows that each time you use the water an additional time, it shows you the percent of water savings that you gain by moving to that additional use point cycle. So if you start at 2 cycles of concentration and then go to 3, you save 19% of the water. If you move from 3 to 5, you gain an additional 15% of savings. And every single cooling tower or evaporative cooling unit has a point at which the use of the water is optimal. And it's very dependent on specifics, but the trick is to try to operate at that point that is optimal for that unit. And the reason that, the reason water chemistry people almost uniformly use to justify operating at a lower or far lower level of operational efficiency than is possible is this whole idea of unnoticed problems. Those are things like a controller sensor failed, blow down valve plugged, all kinds, human error. There are discrete things that actually, events that happen that lead to water waste or wasting money, or most importantly, that cause damage to the unit where the minerals scale up the heat transfer surface. That is so costly and so damaging that water chemistry people just, it's their nightmare, and they don't want to be associated with it. Here's the reality. If you operate a unit at very low efficiency, or you operate a unit at really high optimal efficiency, your risk profile for an unnoticed problem is identical. It doesn't change at all. So we need to break, because it's an event, it's a failure event that is completely independent of efficiency. We need to break this chain as a profession, and when we approach properties that have these units, we need to show them this and show them how to break this chain. In the study, there's a lot of tricks on how to do that. It basically focuses on the idea of controlling the unnoticed problems, identifying them, getting them fixed, so that we can avoid asset damage, which is the reason they give for operating inefficiently. We control the problem, avoid the asset damage, then we can nudge everybody to continuously operate at close to as efficient as possible. And there's an enormous amount of water savings that can happen here. But it takes that measurement of vital signs to be able to find and fix problems, as well as what we refer to as the standard operating procedure, the what to watch habits for people who are there. So at the cooling tower manufacturer, we would have taken everybody there, and we would have said, look, the water flows in, and then the water flows out. And the water, when it's operating correctly, it typically flows out intermittently through this copper pipe that is blow down. And if it flows out this top pipe, like overflows the bathtub, we have that in red because that is bad. It shouldn't do that. And so we just want you to look. If there's water coming out the top pipe, that big pipe is bad. Water intermittently comes out here. If it's flowing all the time, that's bad. We simplify it so that it can connect to their habit when they're walking past. Ideally, they see it. And again, there are quite a few different types of problems that are in the unnoticed problem category. The research study that was funded by a lot of people on this call, thank you Metropolitan for having the ICP program. It gives a really a fairly complete but very clear set of case examples on the individual types of mechanical failures, operational failures, control failures, and for anybody who is looking at how do we gain control of water waste across the evaporative cooling fleet, this is loaded with takeaways and policy recommendations and a lot of data-driven insights.
And I just want to say, I know you think it's going to be boring because it's a cooling tower study, but for anybody who's into it at the cooling towers at all, it's actually super interesting. Usually when I finally convince somebody to read, it's like, oh my God, that was really interesting. So definitely check it out.
Okay, I have to come clean on this one. I was the lead author, but I have to thank Thomas Pape and Bill Hoff and Kent Sovico for helping me write it, because otherwise it wouldn't have that reaction. But at any rate, applying this construct, this formula, outside, inside, and cooling at a property level helps that property operator. It takes the property, gives them the plan, and helps the property operator connect their superpower of management and ideally integration into their culture of operational excellence, because a lot of world-class businesses think like that, and we think that this is how we connect with it. Again, the plan can be really simple. Gets them on a path where they can begin to evaluate other things, but we need them on that operationalization level so that we have the connection and then can add more to it. Organization and city level property success builds to portfolio success, builds to sustainable success, where we as a group can help hopefully create sustainable success across places where it makes sense. And we've covered a lot, and some of it will seem simple, but there are details. Please, this is our thing. Let us, contact us, and don't hesitate to ask questions or clarifications or anything, because this is sort of our passion. Eliminating water waste from the built environment. Tara, you had some follow-up stuff that I know you wanted to talk about.
Yes, thank you both. That was so helpful, and you gave us such great information that should be really useful as we move forward working with some of these facilities or using it at your own facilities. So as you guys, I wanted to go through a couple of WaterSense resources so that you guys know that they exist. And while I'm talking, if you have questions, please enter them into the chat box and we'll get to them in a few minutes. But the WaterSense program has a whole bunch of resources for commercial and institutional facilities. We have best practices, water saving tips, checklists, worksheets, all sorts of things, and links to some of the training webinars that we've done in the past. Next slide, please. If you could go to the next slide. Awesome. So some of them, we have a simple water assessment checklist, and we also have a new operation and maintenance checklist. These are basically just things that you can print out and walk around your facility with and find some ways to save water. Next slide. We also have our best practices guidebook. This is a pretty big, thick book, but there's basically information about every water using technology in a commercial facility, and we go through how to actually operate it and maintain it well as things to think about if you're going to retrofit or replace it. So it's a really helpful guide. Next slide. Also, I would be remiss if I didn't let you guys know that if your building has been sitting idle or it's been closed, before you reopen it, you have to flush the building water system before you do anything or have any occupants. So there's several resources here. I encourage you to check them out. Next slide. We also have several Water Wednesday webinars scheduled for the next couple of months. And these links will take you to them when you get the slides tomorrow. You can check it out. And I think that's the end. So the next slide after that. And so now we're going to get into the questions. So please keep them coming. We have quite a few of them already. I'm going to try to stump Frank and Anneke and try to get them so that they are confused. So let's see if we can get some answers. The first one is, if a commercial property owner has hired a third party for internal property cleaning or maintenance, how do you address challenges associated with using those third parties and getting them on board with this reporting or this concept?
That is our best case scenario for gaining traction, because think about it. The property operator has contracted with an outside service provider, and typically the property operator is just like, okay, take care of my cleaning, or take care of my cooling tower, and they've delegated it, right? As from a water efficiency perspective, if we go in with a clean set of expectations that property operator can delegate to that service provider, the service provider is going to do it. That's your easiest, lowest lying fruit. And we do that with cooling towers. We do that with landscape irrigation. For example, landscape irrigation, some of the things that Aniki was talking about on, okay, we'll identify the amount of water this landscape needs. Now we know it, and to control it, the property operator can say, hey, this is what it says we need. Please help us nudge as close to that with our existing controller and existing processes. And if we need to upgrade something, we will consider it. But my expectation as the person in charge of this property is that you, who I am hiring, are going to do this. Do you have any questions? And if this is unreasonable, please let me know right now. Otherwise, I will expect this to be done. That is beautiful. That's what we can make a lot of traction as a profession by leveraging that exact situation.
And just to follow up a little bit on that, most of the stuff we're going to ask them to do, they're right there. It's not changing job description. It's not anything. A lot of it's just communication and setting expectations. So again, it's a habit stacking. Almost everything that we're going to ask, they're already there. It's just making sure that they are looking for it and then reporting it.
And when we actually are involved in talking with these people, it's just a whole series of head nodding. It's like, yeah, oh, that makes sense. Because we've used the stuff that we talked about in the presentation. It's just so obvious and clear. But if there's a disconnect, it doesn't matter if it's a millimeter or a mile, it won't work. So we connect it. And this is just a perfect thing to connect. Service providers we would make an enormous amount of progress by just doing that.
Awesome. The next question is, I was wondering if drains are usually visible, or are they sometimes obscured by the appliances or devices when looking for continuous flow?
They're oftentimes hidden, and so again, it's finding out where those end uses are and where the drains are and setting it up so that it's either on your route or it's easy to see, knowing where to look. So yes, absolutely, they're hidden, very easy. They can run I was at a facility that had a cooling tower. The cooling tower was outside, but the drain was inside, underneath the cabinet. And the facility manager who had been there 2 years, I heard it running, we found it, and I'm like, oh, is this run all the time? He's like, oh, I thought that it was supposed to. I just walked by and could hear water, because he wasn't a cooling tower expert. The drain was hidden, and there was basically a continuous failure of the blowdown. And so that's a great example. And so that's what we help them do with the routine and the plan, is identify where those are so that they are no longer hidden. I don't know if you have any follow-up.
A list of these things, you're absolutely right. A lot of the times the complex machines, they go to a drain, but the drain will be totally hidden, or it will be hard plumbed. Had a client with a photo lab that had a silver recovery device that was hidden in under a sink, and they had a continuous ongoing flow, and they kept saying, no, we can't find it. And we're like, no, we have a very systematic process for narrowing things in on things that you have no idea exist and finding that leak. Well, we ended up finding that it was going straight to a very, very hidden drain. So the drains let's assume they're all hidden and go from there. Things you can do is you can open up the cap to the sewer line, shine a flashlight in. If the water is running in that sewer line and it shouldn't be, the leak is somehow feeding into that. But there's a lot of,
yeah, sometimes people stack. So we were at a facility a couple of weeks ago now that, they had a water softener that had been just stuff stacked up kind of near it. So the drain was hidden. So that would be one. You're going to, clear that so you can see it. If you have something in the closet, like a reverse osmosis unit or something, you're just going to have to you're probably walking by it, poke your eardrum in there, as you walk by at least once a day. So, yeah, definitely hidden leaks, and it could definitely just need to be incorporated into that routine. So hopefully that answers your question. And then things that are hard plumbs, sometimes you just have to find advanced measurement or something to keep eyeballs on that. So it's just specific to the property, but definitely hidden drains.
What Aniki just mentioned is this idea of how meaningful measurement can illuminate the hidden problems, and that is super powerful. And this is where it's all going. And if the measurement has the routine, the process and procedure to connect to, bam, it then all flips and becomes normal. But there's improvements in measurement. Costs are becoming lower, and the problem is becoming far more complex and impactful. So I think we're going to probably see a lot more integration of measurement guiding some of the identification that, hey, I got a problem. Now the question is, where do I look and find it, and how do I fix it? But hopefully that's helpful.
Yeah, I think that is helpful. And I think sometimes just knowing what those, simple things to look for helps a lot with, getting kind of the army of people that are already out there in the facility to actually be able to fix something or notice something that's wrong.
Yeah, if you could go to a facility and during an audit and did anything, you could just show them where the water vulnerabilities are. I mean, even with that right there, they've got a ton more information than they probably had. I mean, there's obviously other valuable information during an audit, but that's something immediately that they probably don't know because they're not experts. So,
and that is a huge part of the training that we do for water auditors. Is we teach them to go in and diagnose a property, inside-outside cooling, but it's like, figure out what the routine at this place is. Oh, it's a grocery store, and that management is walking around this thing all the time. You connect the look here. Or it's a food process, or it's a food production facility, a big industry, and they have these different people that are doing these different things. You just connect that look in the right place at the right time, so that the routine is connected with the idea, and then it builds, so that we don't have that disconnect.
Excellent. We have another question. Do you recommend flume-type leak meters on overflow pipes?
Well, with an overflow pipe, you're something like a meter.
There's easier ways to do it. What we recommend on the question is on a evaporative cooling unit, you have the overflow, which is like the bathtub overflowed, and then you have the blowdown, which is this intermittent discharge. We would recommend monitoring that blowdown and monitoring the inflow. Flume is a way to do that. There are a lot of other ways to capture the measurement and drive this, but we would measure those 2 points because it's so useful to know the water that's flowing in and then the water that's flowing down. You can actually use that math to derive a lot of other powerful insights. If you measure the overflow, it's like measuring is the bathtub overflowing? It would give you the alarm, but honestly, you'd be able to tell it from those other 2 points of measurement. Measurement is a very, we call it meaningful measurement. So if we measure the wrong, we can do it a lot more cost effectively by measuring the things that actually indicate actionable items that we can use to tell people what to do. So we would measure in and blowdown, not overflow.
Yeah, because overflow, like you said, it's like a bathtub, right? You got a bathtub, the water supply's coming in, you have a drain. That's really what you're interested in. You might have overflow at some points, but you wouldn't really meter it because, again, you're going to be able to see from the water coming in and the water going out, those volumes and whatnot, how the overflow is doing. So it wouldn't really be worth putting in, if we could measure every end use in every facility, that's great, but it's expensive, that's starting to get expensive. So where really is the cost benefit? Where's the point where it is meaningful, as Frank said, and the overflow just wouldn't really be as meaningful, and you could still get that information.
Yeah, I mean, the big takeaway is we would capture that insight by measuring at a point that gives you a whole lot of useful information that you will use in many, many other ways, because we want the most meaningful measurement point. And then Ideally, it's just 1 or 2 points in a building. Everything else makes sense.
Okay, thank you. We have another follow-up question. If a lot of drains are hidden at a facility, I see staff at the facility not wanting to or not caring enough to spend more time, A, identifying, and B, uncovering them, installing advanced metering software. Do you have any tips for convincing these folks that it's worth their time to take these extra steps to monitor the drainage?
Yeah, well, so I'm going to use like a grocery store as an example. So again, I think it's this mentality that people don't care is kind of maybe not terribly accurate. At least that's not what I've seen. Once they have the information, it's sort of like the check engine light in your car, right? I'm driving along, my check engine light comes on. I'm probably going to go get a little piece of black tape and just put it over it and fix the problem, because I don't even know there's so many things that could be, right? So it's sort of stressful because I know I have a problem, but I have no idea how to figure it out. So if I had the check engine light come on and I had like basically a routine of, the information I needed to diagnose where it is in my vehicle, I'd feel a lot more, that would be a lot more actionable. So I don't think it's that people don't care. So think of a grocery store. The property operator does not want problems. They don't want breaks. They don't want extra costs. They don't want to organize service providers. They're trying to make sure their inventory is good, their staff is doing what they need to do. So if they're like the person we talked to, like, no, I walk around the store 20 times a day. If you can show them those points, I have not come across an operator that's like, no, I don't really care about that. They're like, thank you. Now I know that that's there. I know if that's running continuously. I have a problem and I can get ahead of that. So it's not 3 months of incredibly high water bills or a break or something that is going to blindside them and add just one more thing to their day. So I think that the advanced metering has its place. Like Frank was saying, there's going to be a couple of points that are going to give you the kind of heartbeat of the whole facility. You're not going to measure every endpoint. So that's really the cheapest, cost-effective way, is to identify those, show the property operator where they are and how they can incorporate it into the normal routines. I've never had one be like, nah, I'm not interested. I think they're like, whoa, thanks, and that's something they can do.
And just one point of clarification. From the question, I began to think that we may have miscommunicated and led somebody to believe that we're measuring the outflow, we're measuring the drainage. I've never done that. I've never measured the outflow. We've always diagnosed things and found the inflow point that we can measure that illuminates all the vulnerabilities set past that point. So like Aniki was saying, there's 1 or 2 things or 3 things in a building that shine the light on the problem. What we're saying with train the brain to see the drain type stuff is they're walking around anyway, and even if they don't have the advanced measurement, if they look in these drains and it's constantly going, that's a problem. Follow the pipe to the machine, that machine, whatever it is, I don't care, likely has a problem. That's helpful. That's the root. That's the structure, the sort of brain concept that we connect everything else to. They don't want to look into the drain. They don't want to uncover stuff from the drain. If we're bumping into that, as a society, we need to start saying, hey, this is the largest consumer of electricity, and it actually means something. And what that means to me is that the person in charge of that property has not adopted the plan. They didn't say, you know what, this actually means something. It's easy enough that I think can we all do this? All of their staff will say, yeah, we can do that. That's simple. Okay, do it. My expectation is that we do this. So they don't care enough, they probably didn't adopt the plan. And that, if we did anything in this presentation, we got to get buy-in from that property operator that this plan makes sense and it is now part of our routine.
Yeah, and when it's part of the procedure, right, it's not a moral issue or if you care or not. I mean, when you work at a place, you kind of have a job and you have standard operating procedures. So if you can get the property operator to buy in on the plan, it just becomes a way of working, right? It doesn't have to be a moral question. Do you care about water? Do you not? It's just like, oh, here's my job. This is what I do. So it doesn't even have to really come, just like, like the fire station we were at, they put their helmet here, they put their shoes here. When they get back in with the truck, they do this. bam, they turn on the irrigation zones and look for leaks. Doesn't really, you know, it's just sort of, that's where you kind of get into the standard operating procedures.
That makes sense. We have another question about cooling towers. Can I get an indication of cycles of concentration or wastewater if the amount of chemicals changes?
Yes. The amount of chemical thrown into the water flow is well, let's not be distracted by that. What you want at a cooling tower is you want it to use the water, to cycle it, so that it reaches its optimal point of efficiency. Now, the water chemistry person who adjusts the chemical based on a number of different factors will help determine that. The question is how close are they going to set the operation of the unit to that optimal point? The injection of chemical and the chemistry of the water itself and those types of factors, we could get in, read the study. We can do follow-up questions, but I really don't want to put people to sleep right now.
It would depend on the unit, how the chemical is fed. Is it based on time? Is it based on some kind of concentration of something else? So it's like a more complicated question. You can send us an email.
Good question.
We love cooling towers, so send us an email and ask. But yeah, it's possible it's just a deeper question.
We got another similar question. How does the property owner know the optimal cycles of concentration to run their cooling tower to tell the service provider, especially given the fact that cycles of concentration is highly dependent on specific water chemistry to achieve optimal efficiency? I must have read your mind.
They just nailed it. It's okay. You just nailed it. So each cooling tower, you can have 5 cooling towers next to each other. Each one is going to have a personality, but the water chemistry expert will test the water. They'll test the water going into the unit, and then they'll test the water in the unit. And these tests, they need to document. They need to, and there's parameters that they test, and we want that on the report. And then what we want them to do is say, based on these facts, these tests, the limiting variable at this unit is calcium hardness or alkalinity or whatever it is. And I'm going to, if I'm going to take that limiting variable and I'm going to cycle it up to the maximum concentration I can possibly get before it becomes a problem. So they'll say it's calcium, say it's alkalinity, and it comes in at 150, and they say that the max is 450. They're going to take it and cycle it 3 times to get to 450. Well, that's the optimal maximum potential efficiency of that unit, so that it's determined by their testing. So we ask them what the limiting variable is, and then we tell them to cite what the optimal operational target is, and then where we're at. And then we put in a couple of tricks, but this is a service provider. That we're working with a major hospital now, and we're helping them gain control across their fleet by doing these types of, this is the expectation, we want these tests done in this way, and we want the rationale documented so we're all on the same page.
And again, this is something that's already being done. The service provider has to do these tests. When they're on site, they come every month, they do their tests, they kind of check it on the machine, make some adjustments, they make a report, and they give it to the facility. So this is already being done, and we're just making sure, well, it better be being done. So we're making sure it's being done because that's how machines are run. And then they document it, give, again, Frank said, their rationale on why they're running that. So you're just leveraging something the resource you already have, and then you're able to see where you are, where you want to be. That's a common goal that you and your service provider can move toward. So, yeah, that's perfect.
Yeah, there's a lot of really good service providers who have a lot of this information on their existing reports, and a lot of times those reports are filed. So part of the water auditor experience or training that we do is like, just make this meaningful by explaining these couple things and then adding this to it. So now you have that connection point, because we're so close there.
And then that
Yeah.
report becomes actionable. Then somebody gets the report, they're not like, I don't know. They get it like, oh, I'm looking for these couple of things. This is where we're supposed to be. This is where we are. Either thumbs up or something's wrong and I'm going to find out more. So it makes, just makes it a lot more actionable.
So the property owner doesn't need to know the optimal cycles. They're, you know, the service provider is going to be the one to tell them that. They just kind of need to tell them that they want to be saving water and kind of go from there. It sounds like.
They want to be safe. They want optimal, and they want the information that helps illuminate what optimal is documented. That's what they're asking for. So it's already there. They're already doing the test. We just want it put into this level, and then the chemistry person is going to say, well, this is optimal, and this is where I've set. And, you know, I mean, I would do the set point close to optimal because I wouldn't want to have to explain the difference.
Yeah.
But it, yeah, so that's how.
Awesome. Well, I think that's.
I'm going to get really excited about cooling towers, everybody, in case you couldn't tell.
Yes, and you guys will all have a copy of the slides and the recording tomorrow, so you can send us emails. But I think we're going to end things for today. Thank you all so much for joining us. We really appreciate you spending the time with us this afternoon, and have a great rest of your day.
Thanks so much.